was very fortunate to not only do the postdoc working for Mel, and I worked with Mel since 2003. And so it's a great pleasure for me to introduce Mel here in University of Tel Aviv, where I grew up, did all my degrees here, and now it's kind of very nice. I really thank Professor Kleinberg for inviting us, for inviting Mel. So Mel Slater is an ICREA Research Professor at the University of Barcelona in the Faculty of Psychology and a Professor of Virtual Environments at UCL, University College London. His research focuses on virtual reality and technical developments in this field, but he's also contributed to the use of virtual reality in the field of psychology and cognitive neuroscience. He has aimed to bring the use of virtual reality as a tool in scientific research in these areas to the highest level through his publications in PNAS, Neurons, Trends in Cognitive Neuroscience, Trends in Cognitive Science, Philosophical Transactions of the Royal Society, Nature Reviews Neuroscience, and ACM SIGGRAPH. In 2005, he has been awarded the Virtual Reality Career Award by the IEEE, and he's a co-editor in several journals, edited a few books. That was a formal introduction. I will say a few informal words. So as of yesterday, Mel had 19,077 citations on Google Scholar, which we can, of course, measure everything today. That was yesterday. I don't know if it's updated today. So, but, you know, there are many, many good scientists, but you have to realize that Mel has established the whole, well, not single-handedly, but with a select few, has established the scientific research of virtual reality, really setting up a new discipline, not just a technology, but setting up a whole field of research of understanding virtual reality by itself and in its interaction with psychology and the brain. And so you have the honor to see the world leader in virtual reality. Now, there are a few other contenders on the title of leading VR researcher, but it's more like the arguments, you know, between Messi and Ronaldo. Okay, so those are a few people, and I will just, you know, we all know who is better here. And I will give a hint that Mel is from Barcelona. Okay. And having said that, I welcome him.
Thanks very much for that introduction. It was also a pleasure having Doron as a postdoc and to work with him over many years in various projects. And thanks again for inviting me, Professor, and also to Doron for the introduction. So I prepared two versions of these slides. One was full of what I usually do, statistics and p-values and means and so on. And I thought, I looked at the other authors, the other speakers, and I checked with Doron. He said, take them all out because they're not going to be interested in that, just the ideas. So this has very few, no p-values, and also very few statistics in it. So it mainly presents results and ideas. So I'm going to talk about the virtual self. And the questions are, do I have a self? Is the self the body I perceive, that I see when I look, that I feel when I move? Is the self my attitudes, my beliefs, my identity? Or is the self what I do? And this is not, by the way, a talk about philosophy, because I'm not a philosopher, at least not intentionally. So what it's all based on is results. It's things we found using virtual reality over the past few years. So the first thing I'm going to look at is the self, my body. And the question is our body relatively fixed? Or is it something that only changes slowly through time, through aging, for example? And we tend to have the idea that our body is relatively fixed, that it does change, but the change is, like if you look at pictures every 10, 15 years, you'll see, yes, there's been changes, but they're very, very slow. You don't notice on a day-to-day level. But in recent years in cognitive neuroscience, have addressed the problem of how does the brain represent the body, and through this it studied various illusions and found that in fact our body representation is extremely plastic. And it's been discovered that it's very easy to generate body transformation illusions. So how does this work? This is like a paradigmatic example. So first of all, what do I mean by a body transformation and how does it occur? Well, in the methods that's been used in cognitive neuroscience based on multi-sensory integration, where the multi-sensory integration, which is giving us evidence about our body, has a contradiction involved in it. And the way the brain resolves this contradiction is by producing an illusion. And here's a very famous example. So here, maybe it's good if we could have at least the front lights off, so it could be easier to see. Here, the subject of the experiment is this one, the one at the back. He has his eyes closed, and the person in front is only needed for his nose. He doesn't play any other role. What the experimenter does is she's tapping the subject's nose and simultaneously using the finger of the subject to make it tap the nose in front. So this is synchronous tapping on the nose of the subject and on the nose in front. So from the subject's point of view, everything is almost fine. What's happening is he's feeling a tap on his nose, and he's also feeling on his finger a tap on the nose. So the brain tries to integrate this into one overall percept. But there's one problem, which is that the arm is outstretched. If he was doing this, there's no problem, but the problem is the arm is outstretched. So of course the brain could just generate confusion, but it doesn't like confusion, it always likes to have a story. And the story it gives you, which is impossible for me to describe, but you could try this yourself later, is it gives you this illusion. It gives you the illusion that the nose has become very long. Again, I can't describe that, you have to experience it, but it's very, very strange feeling. It doesn't work on everybody. When we ran this in an exhibition once, it worked on about 70% of people, and it's quite fast. It's not like you have to be standing tapping for half an hour. It's a couple of minutes, if that. Here's another example of contradictory multisensory information which results in an illusion. This is a rubber hand that's placed in an anatomical plausible position in front of the subject, and this is the subject's real hand, which is out of sight. It's hidden by this block of wood. So what the experimenter is doing is synchronously tapping on the rubber hand, on the real hand, and also the subject can see this visually on the rubber hand. So from the subject's point of view, it's like before, like with the nose one. He's seeing tapping here, he's feeling it here, they're synchronous. So because of the synchronicity, the brain thinks, aha, okay, there should only be one thing going on here, my hand is being touched. And so what happens is that the feeling of what your hand is moves from here to here. So the proprioception shifts from one hand to the other. Again, it's a very interesting, strange feeling, and it can't be described, it has to be experienced. And again, you can test this very easily. You just need a glove that you fill up with something and a sleeve and put it in front, and you can actually test this. If the tapping is not synchronous between the felt tapping and the visually seen tapping, then this illusion doesn't happen. The same with the nose one. If the tapping is asynchronous, it doesn't work. So one method people use to show that this was something real going on, of course it's a subjective illusion. You can ask people to do ratings of how much did you feel the hand is yours, but also you can do more objective tests, and there's also been a lot of brain research on this area. So if before the experiment you say to the subject, close your eyes, point with your other hand under the table where you think your hand is, of course they'll point to here. But if after some time of tapping, a couple of minutes of tapping, you ask them again, close your eyes and point to where you feel your hand is, they'll point more towards this hand. So that distance is called the proprioceptive drift, and it's found again and again in many, many, many studies. This paper was first published in 1998 in one-page paper in Nature, and it's now had nearly 2,000 citations. So there's a whole industry built up around this one simple illusion. So here's an illustration of how this might look. This is, of course, the rubber hand. This is the real one. We put gloves on both to make them look the same, but that doesn't really matter. So you have synchronous stroking and tapping. So, as I said, it's a very powerful illusion. People respond when you attack the rubber hand, and if you do the tapping asynchronously, they don't respond like that. So the next question is, as I said, there's been a lot of work on this, but the obvious thing to ask is, can you do the same with the whole body, not just with a hand? So you could do the same thing with the leg or the different hands or the fingers and so on. All of these things have been done in these hundreds of papers that have been published on this illusion. In 2008, the group led by Henrik Ersson in Stockholm, he carried out a very, very similar experiment, but using the whole body. So what he did is he took a mannequin dummy and put a pair of cameras on top, pointing downwards. And then the subject was wearing a head-mounted display, again stereo, with two displays inside, one for each eye. And provided the subject looked down, he would see, in substituting his own body, he would see the mannequin body instead, because what he sees through this head-mounted display is the visual images coming from this stereo camera. So once again, the experimenter synchronously taps on the stomach of the participant and on the mannequin. So what the participant is seeing his mannequin body being tapped while he's feeling up on his real body. And once again, he gets the illusion that the mannequin body is his body. Of course, you always know this is a perceptual illusion, it's not cognitive. You know it's not true, but you can't help but have the feeling that this is your body. It's like when you see a cube drawn with lines on a page, of course it's just a number of lines, but you can't but help see it as a cube. It's a perceptual illusion. This is the same thing. So this is how this works. The subject would see from first-person perspective the mannequin body. He sees it being tapped, and he feels the tapping on his own body. And then when you attack that body, they respond. So they get a big spike in their skin conductance, which indicates a response to the threat. So how do we do this kind of thing in virtual reality? Well, there's many ways. The most powerful way we find is this. So the subject, she's wearing a head-mounted display, and she's wearing a suit that will track her movements and feed those movements to the computer. And what the computer does is update the virtual body in real time. So when she looks down at her own body, she won't see her own body, she'll see the virtual body instead. And when she moves, she'll see the virtual body moving the same, more or less, not exactly, but more or less the same as her real body through the tracking. So what happens here is that when you do this, even though the body doesn't, and this is a point I'll keep coming back to, even though the body doesn't look like you, it could change in gender, it could change in race, it can change in size, many different changes can happen. People still have this perceptual illusion that the body is theirs. And in a way it's not surprising, because in our whole lives, whenever we look down at our body, what do we see? Our body. Whenever we move, what do we see moving? Our body. So it's a very, very strong prior probability that if you substitute the body in this way, that people will have the perceptual illusion, not the cognitive illusion, but the perceptual illusion that this is their body. And you can do other things as well in virtual reality. When a virtual object would strike the hand of a participant, a virtual hand of a participant, we can arrange it so that they would feel something on their real hand. So we can also do exactly like the rubber hand illusion, but this is actually, turns out to be more powerful, the visual synchronous movement. So there's overwhelming evidence, I mean many studies now, that our body representation is highly malleable. And there's a very nice quote from Amel and Ramachandran, who say, taken collectively, our experiments suggest, this is based on rubber hand illusion, that the so-called body image, despite its appearance of durability and permanence, is a transitory internal construct, a temporary shell, that can be profoundly altered by the stimulus contingencies or correlations that one encounters. So this is the idea, this multisensory information gives you evidence that your body is different in some way, and the brain typically will integrate that information, produce an illusion, and that illusion is a very strong perceptual illusion. Now I'm going to move on to the second one, which in a way is more interesting. I mean, so yes, we can give people the illusion that their body is different, but what are the consequences of that? So a series of experiments have illustrated how when we manipulate the body representation, then it has important implications for self-processing. So three things I'm going to show, three experiments. One is making an adult become a child. And the second one is around the idea of reducing racial bias. And the third one is the most crazy of all. It's a confusion between yourself and others, and we make use of that in a counselling application. So the first one, becoming a child. So this was an experimental study where we had 32 people, adults, enter a virtual reality, and they were either embodied as a child or as a shrunk down adult of the same size. I'll come back to why we did that soon. So that when they're in the virtual body, it's either a child body or an adult-shaped body, but shrunk to the same size as the child. And these two groups, there was no differences between them with age or gender or anything like that. They were very comparable. So they saw themselves from 1pp, first-person perspective. So they look down, they see the body, and also they saw it in a virtual mirror. And what we measured was a kind of standard questionnaire on how much they felt the body was theirs. And then before the stimulation started, we trained them on estimating sizes of objects by using their hands. So they kept having, we showed them objects, they would put their hands, like, is this far, this big? And then we'd say, no, that's wrong, you're too big, and then they would adjust. And we kept training them again and again, many times, until they got it right, till they learned how to use their hands to estimate the size of objects. And we did this size estimation before the stimulation and after, and we were interested in the difference between those two. And the last thing we did is an implicit association test. This is I'll come back to this later because we use it in the racial studies as well. This is a reaction time test that tests how much they identify themselves with various categories. So some are childlike categories and some are adult-like categories. And this is not a questionnaire, it's a very fast reaction. You see two images and you have to press a left button or a right button. And depending on the outcome, you've identified yourself more with childlike or adult-like attributes. So here's a video of how this experiment looked. The music wasn't part of the experiment. So this is the size estimation testing that they do beforehand. They're wearing a head-mounted display and a body tracking suit like I showed you before. And we show these boxes that they have to estimate in a neutral scenery. So here she's estimating the size of an object and she gets some feedback saying, no, it's too small or too big or whatever. Then we always do this. We ask them just simply to describe what they see, just to get them used to being in the virtual reality and looking around and being comfortable.
Hay una planta, al fondo hay una mesa con 4 sillas, hay un cuadro.
And then we substitute their body by either a child body or an adult body shrunk to the same size as the child. So the top one is the child body, the bottom is the adult body, and they don't, all they do is this, there's no task. They're just told, move around, move your body, look at your body, look around. There's no particular task to do. And we put that virtual woman there just to give us an idea of scale. Nothing happened with that. And this is very powerful. When you look down towards your feet and you move your real feet and you see the virtual ones move, this is really powerful because we're not very aware all the time. We know our feet are down there, but we don't know exactly where they are. So if the tracking is slightly off, if the placement of the virtual feet is slightly off from the real feet, it doesn't matter. And then after that, everything disappears and they're asked to estimate the sizes of objects again. So what happened? The perceptual illusion of ownership, so this is on this standard questionnaire that we use, the perceptual illusion of ownership was high in both conditions. In other words, it didn't matter if they were all the subjects were female. It didn't matter if they were embodied as a child body or an adult body, it made no difference. The illusion was high and strong. But high and, yeah, it was high. Both groups overestimated the size of objects. I said I would have no statistics, but it has a little bit. This axis here is the difference in the averages after, take away before. The blue ones are those in the adult body, and the reddish ones are those in the child body. And as you can see, that it should be 0 if there was no estimation. But there's always overestimation, whether you're in the adult body or the child body. And we knew this from a previous study, again by Henrik Ersson, who had embodied people in a small doll-like body using the same technique as before with the video cameras and so on. And they found that when you embody people in a small body, you overestimate the sizes of objects. So we knew, because both of our virtual bodies were small, we knew people would overestimate size. But what's interesting is they almost doubly overestimate the size when they're in the child body. So simply the form of the body, not the size, but the shape of the body, making it childlike, led to this double overestimation. And the other result is, remember I said that we did this, it's called an implicit association test, where you identify yourself with the rapid responses as more childlike attributes or adult-like attributes. Those in the child group identify themselves much more with childlike attributes. So up here, this is the mean of those in the child group, this is the mean of those in the adult group, and you can see this is more childlike and this is more adult-like. The difference was very pronounced. Now, you might say, well, how do we know that's got anything to do with the body ownership? So what we did is we did a subsequent study where we made the movements of the virtual body non-synchronous with yours. So everything was the same, the subjects were in a child body or an adult body. Their task was to move, but the virtual body didn't move the same as they did. So in other words, we extinguish the body ownership. We also find an extinction of these differences, so they overestimate the size, but they overestimate the size the same in the adult body and the child body. And again, there's no differences in the sense of identity in the implicit association test. So when you eliminate the visual, the motor, the synchrony between your movements and what you see your virtual body do, then the differences, all the differences we found before, they vanish, and also you have a low illusion, no illusion really of any body ownership over that body. So just a few moments of multisensory stimulation, I mean it was 5 minutes or so they did this, is compatible with the hypothesis that this body I see is now my new one, and it leads to these changes in size perception and self-attributions. Now I'm going to move on to another application, another experiment, but it's quite similar. It's in the context of racial bias. So here we don't change the age of the person, we change their race. So we know, of course, that people tend to categorize others into flexible themselves into in-groups and out-groups. And racial categorization is apparently something quite deep-seated. But we wondered whether we can use these embodiment techniques to influence this, whether we can change someone's bias against outgroups, in particular in this case a racial outgroup. So in this experiment we had 45 white, light-skinned females, and they were embodied in different kinds of bodies. Some of them were embodied in a white body, some in a black body. In order to test whether our results were to do with race and not just difference, we embodied some in a purple body. And there was another group who we didn't put them in any body, they just saw a body in the mirror, in the right place in the mirror, but it didn't move like them. And we used the same setup, a body tracking suit and a head-mounted display. And we wanted to see, well, I'll come on to that in a minute. So here, first of all, this is how it looked, very, very simple. She's just standing in an empty room, and if she looks in the mirror, she'll see the virtual body reflecting her own. It will move like her. In this particular case, it's the dark-skinned body. And they do this for 12 minutes and nothing much. Some people walk by them, but nothing much happens. They don't have any task. It's very simple. So the experimental design in technically is called a between groups design, which is that each person only has one experience. Black body, white body, purple body, or no body. So 15 were embodied in dark skin, 15 in light skin, 15 not embodied but saw this body in the mirror but didn't move like them, and 15 in the purple skin. And then days before the experiment, we used one of these implicit association tests to measure racial bias. This is the biggest studies on implicit association tests have been done by Harvard. We've done thousands and thousands of people across a whole number of different categorizations. In this particular one, it's racial. And the way this works, it's really very simple. Again, it's a very fast reaction time test where you're asked to pair dark faces with negative words and light faces with positive attributes. And if you do that faster than the other way around, dark faces with positive words and light faces with negative words, then that's an indication of bias. Again, this is not a questionnaire, it's not something conscious, no one's asking your opinion. You're just asked to quickly press this button or that button to make these kinds of pairings. And by the way, this implicit bias, it doesn't reflect your views. So you can be, somebody can be completely non-biased in their explicit beliefs and be completely against prejudice and so on. But that wouldn't necessarily reflect in the scores they get for this. And what it's been found is that implicit bias predicts more of one's behavior rather than explicit bias. And by that I mean very simple things like you go on a bus and who unconsciously do you choose to sit next to? This kind of automatic responses that you don't think about, you just do. So implicit bias is more to do with behavior, it's not to do with your beliefs or your politics or your attitudes. There's a big controversy around these tests, but the evidence seems to suggest that they do correlate with behaviors. So what did we find? As before, all but the group that didn't have the body had a strong illusion of subjective ownership over the virtual body, irrespective of whether it was black, white, or purple. But only those in the black body showed a decrease in their implicit bias after exposure. Again, I couldn't resist showing a graph. This is the difference between measuring the implicit association after takeaway, before takeaway after. So, sorry, after takeaway before. So it reduces only, the implicit bias reduces only for those in the dark-skinned body. However, we measured that immediately after their experience. What we wanted to know really was, how long does this effect hold? Maybe it lasts for 1 minute or 10 minutes after the end of the experience and then it disappears. So we did a subsequent study where we measured it not immediately after, we measured this implicit bias 1 week before the exposure and then 1 week after the exposure. We also gave multiple exposures. This is recently published. So the way it worked, there was like this, 3 groups. So group 1 had the pre-implicit association test, and then 1 week later they had their virtual reality exposure, and then 1 week after that they had the post-implicit association test. Another group, similarly, they had the pre-test, waited 1 week, did their first exposure, waited 2 days, did their second exposure, and then 1 week later they had the post-test. And finally another group did it 3 times, and then 1 week later their post-test. So this was the design of the experiment. Again, it was all females, University of Barcelona. This is how the characters look, white body, black body, and the pretext we used, why those of them who did had to keep coming again and again 2 or 3 times, is that they were being shown a Tai Chi lesson by a virtual Tai Chi teacher. And the reason we did that also is they had to move, they had to copy the moves of the teacher, so they would see that in a mirror and also directly. So I'll just show you the video. So So once again, they wear the body tracking suit. They put on the head-mounted display. And first of all, as usual, they just have a period where they get used to it. So they're told, this is someone embodied as the white body. They're told, move, look at your body, look around, describe what you see. They're just getting used to being in the virtual reality. This is someone the same in a dark-skinned body. So once again, just told, move, look around. And then the teacher starts, and they're told to either follow the teacher immediately or try each one afterwards, after they'd seen it. And the pretext for this was that this was the pretext for making them move. So the teacher just showed various moves. They had to copy them as best they could. And we'd had two different kinds of teachers, Asian-looking one and a white, European-looking one. And that made no difference. And then they did this implicit association test. So what happens is, as before, high subjective illusion of body ownership, irrespective of whether they had the white body or a black body. This really emphasizes it's not the appearance of the body, this multisensory integration, which is most important. Second, reduction of implicit bias, even after 1 week, even after 1 week after the exposure, but only in the black embodied group. And there was some small effect of multiple exposures, but not much. So the darker ones are those embodied in the black body. This shows reduction in implicit bias, and it only happens for those, happens significantly for those in the dark-skinned body. So it's a similar result as before, but the nice thing in this one is that it's not taken immediately after the exposure, but waits 1 week. So we know the effect lasts 1 week. Of course, we don't know if it lasts 1 week and 1 day, but these are very complicated studies to do. So these results, when I first got the first result, the one I first described, I was worried because I somehow couldn't see how 10 minutes of this exposure would result in a reduction of something you think is so deep, like implicit bias. But unknown to me, another group led by Manos Sekiris in London, he was doing a very similar thing, but instead of, he didn't have virtual reality, he didn't have a whole body, he just used a black rubber hand and did the same thing and found very similar results to us. So after that, we got together and wrote a joint paper reviewing the material that we both independently found. And, And the most recent study we did is actually with Beatrice Herzliya, who's now IDC with Doron. She spent a few months in our lab in Barcelona, and she had the idea that let's not look at this implicit bias, let's look at another unconscious behavior. So it's known in the social psychology literature that if you're in rapport with someone, if you're in a kind of harmonious situation with someone, you'll tend unconsciously to mimic them more. So I don't mean you deliberately copy, I mean your behaviors, like one may be swaying to the side and the other one may be doing something similar that's in synchrony. One might go like this and the other one go like that. So you're not aware of these things. Typically, if you watch people in a restaurant, you can tell who's in harmony and who's not by how much they're kind of doing a dance together. So her idea was that we did a study where we put people in a virtual reality with a partner. And each person we put in either had a black body or a white body. And their partner either had a black body or a white body. And what we found is that those who had the same virtual color body as their partner mimicked their partner more. So we made the virtual partner do some things like this, and hands on hips and scratching and stuff like that. And we counted the number of times that the subject would mimic the partner. So they tended to mimic the partner more if they had the same virtual color body. So if I'm in a black body and my virtual partner's in a black body, I would mimic them more than if I'm in a black body and my virtual partner's in a white body. And similarly, if both of us are in a white body, there's more mimicry. So this is a very, very nice test that there's something really deep happening here. It's not just kind of you know, it goes beyond the implicit association test because it's real, observable, unconscious behavior, and the people in this experiment had no clue that we were measuring this. They didn't know why. They were just describing some pictures along with their partners. They didn't know we were measuring this mimicry. The last one I want to describe in this context of changing the body is the most strange one. It's swapping bodies. It's in the context of self-counseling. So this was initiated by the idea of, well, in virtual reality, I don't like to use virtual reality as a simulator of reality. There's no point to it in that sense. Reality is better. So I always like to try to do things which go beyond what you can do in reality, to do things that are not possible, but nevertheless possibly useful. So it started with this idea that our internal dialogue is a problem-solving mechanism. We do it all the time. But of course, when we have our own internal dialogue and we discuss with ourselves some problem, we can only really do it from our own point of view. And from our own point of view is probably the reason we have the problem in the first place. So suppose we could externalize this other self, the one you talk to, instead of me saying, no, I should have got up early, whatever it is, I should have done this, I should have done that. I'm not saying it to me on the inside, but I'm saying it to someone I see over there. And then I become that person I see, and I hear myself just say what I said, and I start having a dialogue with myself. It sounds crazy, but it's possible. So have a dialogue with yourself as if it's with another person, but that other person now is not just another person, but it's somebody who intimately knows your problems because it's you. But you're seeing it now from another perspective, because it's just another version of yourselves, but with this different perspective. So how did we do this? Why we use Sigmund Freud, I'll explain later. It wouldn't have been my choice, but I'll explain this as it goes along. So first of all, there's a real person, a subject, we scan them, we make a copy of their body, virtual reality copy. So when he looks in the virtual mirror, he sees his own body reflected back. And the other side of the room, he sees Sigmund Freud. So when he looks in the mirror, he sees himself. In this case, they were told to explain their problem to Freud. And then he explains the problem to Freud. Like, the typical one was, my girlfriend or boyfriend, no, they're all men. My girlfriend's gone to live in another country and I miss her and don't know what to do. Or my boss is treating me badly. When they finish, they are moved into the Freud body. And then after they've explained the problem, they are in the Freud body. So if now they look in the mirror, they'll see Freud's body, and if they look down at themselves, they'll see Freud's body. And once they're in that body, from this new perspective, they hear and see themselves explain the problem. And then, after this, we record everything, and they explain the problem, they hear and see themselves explain the problem. And then they can respond and say, well, I think you should talk to your boss, or whatever it is, the ideas come to you when you're in that body. And then they're back in their own body, and they hear Freud say what you just said, but in a disguised voice. So when it's played back, it's a voice at a lower pitch. People don't quite recognize their own voice. So it just goes back and forward, having this dialogue between yourself and Sigmund Freud. But you're both of them, and you always see and hear what the other one just said. This can go for as many steps as the person wants. During the asynchronous condition. And we had an asynchronous condition and so on, but I won't go into that. So what happened was that body ownership was high and the same in both their own body and the Freud body. And this is very interesting because this, in the first experiment we'd ever done, the body we gave you was your body because we scanned it beforehand. And so when you looked in the mirror and looked at yourself, you were wearing the same clothes, you had the same face and everything. But still, you still got a high level of, the same actually, level of subjective body ownership in your own body and in the Freud body. These are all men in their 20s who did this, and the Freud body looks much older. It illustrates that the body ownership is highly dependent on this multisensory stimulation. It's not dependent on appearance. Well, provided it's humanoid in form, typically, we always find it works. So what happened is that everyone sorry, I should have said there was another condition where the one on the other side wasn't Freud, but another copy of you. So you're literally talking to a copy of yourself. It didn't matter though. Everybody improved their mood and happiness with respect to their problem, but those with the Freud body, Freud as their counsellor, they improved it more. They improved more. So I could have a dialogue with another copy of myself, and my happiness or mood with respect to my problem would improve. But if the one I had the dialogue with looked like Freud, is more. So this is something more than simply the multisensory perceptual embodiment. It's more of a kind of cognitive aspect to it as well. Somehow I see my problems in a slightly different light if I see it not just from the perspective of my own body, but my own body as someone else, me as someone else. So actually we got a grant to take this further. We're carrying out 2 clinical studies, one at the University of Barcelona, led by clinical psychologists, one at the University of Barcelona, and one at the University of Oxford. So we don't know if this, in the end, is going to be therapeutically useful. So finally, the results suggested that being embodied as Freud results in improved self-counseling compared with dialogue with self-representation. Why did we choose Freud? We wanted to choose someone who everyone would recognize, but we didn't know who. And we had a survey from the same population asking people, to whom would you like to discuss a personal problem? And third was Nelson Mandela. Second was Angelina Jolie. And first was Freud. So we had to choose Freud. For those of you who know this area at all, this is very similar to what in Gestalt therapy they call the empty chair technique. The empty chair technique is typically used in a situation where you have a problem with a significant other, a parent or whatever, and you have an empty chair and you say, "Mum, I really don't like the way you treated me," and then you go and sit in that chair, and then you become her, and then you answer back to yourself, and so on. So it's similar to that technique, except that here it's not left to the imagination, it's really direct. And actually we went to a psychology conference and we embodied people, actually a Gestalt therapy psychology conference, and we embodied people there as Fritz Perls, and they were really blown out by it, to be Fritz Perls, their hero, and giving counselling to themselves. Now, so what we've seen is that a few minutes of multisensory stimulation provides evidence of a different body. It can result in changes in implicit attitudes, behaviours, even cognition. And the last thing I want to look at is there a constant self in what we think we do? There isn't a constant self in how we appear and our attitudes, behaviours and so on, but is it in what we do? And this is an issue of agency, which is the attribution of authorship of actions to ourselves. So I pick up this bottle and I know I did it. Agency can also be manipulated though, and this is what we did in this last one. So we considered what happens when you own a virtual body and it does something but you didn't do it. It does it spontaneously itself. In this case it was speaking. So we embodied people in a virtual body using the same techniques as before, visual, motor, synchrony, and at some point that body said some words. And so half of the group had a synchronous real body with virtual synchronous real body movements. So they look down, they see a virtual body, they move, the body moves with them. And the other half had asynchronous movements. The body didn't move with them. So they didn't get the body ownership. At some moment, that body spoke 45 words. But one thing we did is that it spoke always in a higher frequency than a participant. So a higher pitched voice. So, in other words, before the experiment, we asked people to speak, we measured their fundamental frequency of their voice. Then they had the VR exposure. Towards the end of the VR exposure, their virtual body spoke, and it had a higher fundamental frequency than this. And then after the experiment, again, we measured their fundamental frequency. And one of the things we're interested in is this difference, the after minus before of the fundamental frequency. So here's again how this one looks. So first of all, we measure the fundamental frequency of their voice before the experiment, and they do say these 45 words. Extract the baseline fundamental frequency. It's the same setup with a head-mounted display and a body tracking suit. I'll wind this board a bit. I'll get it in a minute. So this is the same as before. This is the synchronous condition. The body moves the same as they do. And again, as before, they have no task. They just have to stand there and make movements and so on. This is the asynchronous condition. So we expect this to give low level of body ownership. As you can see, the body has its own independent movements. The only thing that's correct is the head, and where you look is always correct. Otherwise, people get sick. We put some, I'm not going to go into this, but we also had some vibrators that vibrated or not when they spoke or not. And then what happens is that, you can't hear it here, but this body would just start speaking and the mouth would move synchronously with the speaking. So it wasn't the person speaking, but their virtual body. So what did we find? Those in the synchronous condition, of course, had much greater perceptual illusion of body ownership, but they also had much greater illusion of agency over the speaking. So they knew they hadn't been speaking, but if we asked them, how much did you feel that it was you who was doing the speaking? Those in the synchronous condition would answer much more strongly than those in the asynchronous. And the other thing which was really amazing was that the fundamental frequency of the voice for those in the synchronous condition was higher than it was before. In other words, it was mimicking the fundamental frequency of the voice of the virtual character. So then, so in other words, they not only had the strong illusion that it was them who was speaking, but they also made their own voice adjust, the fundamental frequency of their own voice adjust towards that of the virtual voice that they heard. So then we wondered, is this just body ownership, or is it specifically because it's generalizing from the fact that I do actually have real agency over the body, because when I move, the body moves with me. So I already have agency over the body. Is it body ownership plus the generalization of that agency? So we ran another experiment where we induced body ownership not through visual motor, but through visual tactile. So what happens there is that some balls are striking your virtual body, and as they strike your virtual body, you feel them. So it's just like the rubber hand illusion. You get the illusion this body is yours, but without movement, apart from the head. So what happened when we replicated this way is that we got the same subjective illusions. Yes, they thought they had a strong sense that it was them who did the speaking, but we never got the fundamental frequency findings. In other words, they did not speak in a higher pitched voice afterwards when we induced body ownership in this different way that didn't rely on movement. And by the way, these findings we replicated in yet another study. We found the same thing again. So this is the standard forward model that neuroscientists use to explain agency. They say, you plan to do a movement, your brain makes a kind of simulation of that movement, an efference copy, and that simulation predicts the sensory input that would happen if you did that movement. So the brain will predict that. And then there's, so that's all going on as a simulation in your brain. But then there's reality, so you actually move, the world responds, and you get that sensory information. And then the brain compares your predicted sensory information with the real sensory information. And if those predictions match, it says, okay, I'm the one who did this. You get this sense of agency. So that's what I think is happening here. That here we have, this is my body, and it's doing something, X. So I must be doing X. But that body ownership had to have been induced through synchronous visual motor actions. It's like the brain is saying, ah, it's my body, I'm moving and it's moving. Ah, it's talking, so I must be talking. So I better prepare to talk in the same way that I'm talking. So it makes a motor plan to carry on talking that way. So it recruits the motor cortex and generalizes from that. Then it prepares motor commands to realize that action, which was talking. And then when later you ask them to talk, it comes from that prepared plan. So again, we don't know how long this lasts. It's probably just a few minutes after the experiment. But it's interesting that you can manipulate agency in this way. So the unitary, going back to the beginning, a constant unitary self is not tied to the unique, unchanging body, since our brains seem to quickly accept a radically changed body. It does not tie to our attitudes, our behavior, or even our identity, since these can change depending on the body, as we've seen in these experiments. It's not tied to self-attributed actions, because we've seen, it's not just this experiment, but there's other experiments in cognitive neuroscience that show you can have false agency, illusory agency, where agency can be falsely self-attributed. So what is the self? This is where I turn out. And how do we do all this? Of course we use virtual reality, but we use virtual reality as a powerful tool in these studies, because and also it illustrates the unique ability of virtual reality to change the self. So finally, it's an excellent tool for the study of body representation, and it touches on issues such as the self. Critical aspects of the self can be altered through appropriate multisensory interventions, and nobody really knows the duration. We have one study where we at least found it lasts for a week, and we've not explored the mechanisms, the brain mechanisms involved in this, and this is still very much an open question. And it's an important new area for the exploitation of virtual reality, which is change the self. Virtual reality, you usually think of it as changing where you are. What we're showing is that you can change who you are as well. So there's many, many people been involved in this work, and it's had also a lot of European funding. All but one of these projects Doron was in as well. So I'll leave it at that.
I will try to be a bit more speculative at the risk of talking nonsense. So please feel free to let me know afterwards if what I'm saying makes sense. But what I'm going to talk about, so this is my research lab in the Interdisciplinary Center in Herzliya. We do virtual reality and brain-computer interface. I'm not going to talk about virtual reality because everything I know about virtual reality I learned from Mel, literally. So I'm not going to talk too much about virtual reality. I'm going to talk, well, I do know a few things that Mel doesn't know. About virtual reality, really, there isn't much. So I prepared this summary, which is like, what did I learn about the self from working in this community of scientists led by Mel, but with really some of the best neuroscientists and technology people in Europe and in Israel, quite a few people from brain science and from technology. So I tried to prepare a few speculative comments with some examples from research. I hope it makes sense. So the first thing you have to get to know, so we have in our research projects, we do have one person from the humanities at least, maybe more, which is Thomas Metzinger. He's a philosopher of mind, and we're not going to see the whole video, but we're going to try to see a little bit.
את יכולה להזמין דנביס בכל שעה, בכל מקום. רעב, דנביס, ותוריד את האפליקציה.
Somebody has to sponsor these. So this is a talk about the Verret project, which is a really interesting project we're about. And this is what Thomas has to say about the self.
Are you really sure? I believe nobody in the...
Okay, so this kind of
Never was.
smart technology where it's split screen, but it's not my Mac, you know what, I'm not going to mess with Mel's Mac. So you have to trust me, there's a TEDx talk by Thomas Metzinger,
well, let's see,
which he
it's
explains.
But they have to see that. Yeah.
Well, anyway. I think we need to drag it somewhere.
Can you see it on the screen?
No. The Mac is just really, really smart. Yeah, that's good. Okay. I'm not going to be able to stand.
You call Mel again.
Scared. Yeah. No, I didn't want to show you.
Good afternoon. Today, I want to show you why it is literally true that there is no such thing as a self. The self is not a thing, but a process. It is a very interesting and fascinating process. It is that special process that gives you the conscious experience of being someone. And I've been interested in this process for a long time.
Actually, I wasn't going to show you the whole talk. You can watch it on YouTube. And what I did was, so I will try to very, very briefly. I mean, you should watch this video on YouTube.
It's well worth watching.
Because it really it gives a lot of respect to our research that we did here together with Rafi Malak and Weizmann. So you can find more about that. But the point that Thomas is trying to make is that I will try to make it oversimplified. I think this will be doing injustice because Thomas wrote 700 pages, at least in one very, very heavy philosophical text called On Being No One. So I will explain this in 3 bullets. So the argument, but for me as a computational scientist, my PhD was in AI, it really makes a lot of sense. From a computation point of view, the self is a really easy problem. I'll show you why. So the brain runs a simulation of the world, of course, as you all know. And then our body is an important part of the world. Okay, so your brain processes information. And there's always this invariant, which is us, right? We are always there, right? So when the brain builds, gradually more and more complicated representations of reality, obviously our body is a very important part of that reality because it's always there. And so it develops this, if I was building a robot, we build virtual humans, it makes a lot of sense for them to have a representation of themselves. And so our body is an important part of the simulation, and this is how the self emerged historically, evolutionarily. Okay, I'm not going to get into my subtle in-agreements with Thomas. I don't think it means that we don't have a self, but I don't think we have to get into that now. So this is one comment. Okay, from a computational point of view, it really makes a lot of sense that the self would emerge in biological organisms. The next point is something that I learned from my work in the cave, in the virtual reality cave in my years in London as a postdoc working with Mel. So we had all these experiments. It was really interesting to see, so I'll give you 2 simple examples. So in this example, this is a very classic study called the pit room, which was replicated in several places, several labs. And you go in here, you get used to the virtual reality, and then you step here, you have to go around here, grab something from the chair and go back. But there's a pit in the floor, okay? You look down and then you see the room below, and you're supposed to have an illusion of fear of heights. And then some other people replicated this study with all kinds of tricks. You see, so here you're standing, you're wearing the virtual reality HMD. You think you're standing on a verge of a cliff, but actually it's just a 1 centimeter piece of wood, but it gives you a very strong illusion. All these cues to the brain give you very strong illusions, so you get a sense of fear of height. Now, when you look at the subjects, you get all kinds of subjects. When you observe them, when you measure them. The subjects who clearly have a fear of heights, the subjects who say, no, I don't have any, you don't think that they really have the fear of heights from this virtual reality simulation. And there's a lot of subjects which say one thing, but their behavior tells a different story. Okay, they tell you, in questionnaires and in interviews, their subjective reporting is like, no, it wasn't scary, come on, But when you measure their body language, their physiology, heart rate, stuff like that, you see that if they stand on a ledge, they get a fear of height. Okay, so are these people lying? I don't know. We will get back to that. Then there is there's another set of studies that we ran, which had, this was like a simulation of a bar, okay, music, background music, a few virtual characters. This was more or less 10 years ago, or more than 10 years ago. So, you know, the graphics wasn't very impressive. So you bring subjects to the laboratory, you let them interact with these virtual characters, and it's supposed to be a social simulation. And people come out of the experiment saying, well, you know, the avatars are not very convincing, the graphics is terrible, you have bugs, you should fire your animators, whatever. But again, if you take their measurements scientifically, like Mel showed in his talk, and using either neurophysiology, heart rate, skin conductance, all kinds of behavioral cues, you see that they respond. Once these people look at you, you miss a heartbeat, or you have changes in your body language. So something is going on here. I don't think these people are lying. I think these people, my interpretation, and again, this is an interpretation, is that these people have at least 2 levels of response, okay? And it goes together with this evolutionary view of the emergence of yourself, or of your brain, in this case, where, you know, and this goes together with things that are discussed by neuroscientists, okay? So this is a view from Joseph Ledoux. He's one of the top neuroscientists of emotion. So you can find a diagram like this in his textbook, where he says, look, you have this it's actually a very small part of your brain called the amygdala, which responds to fear, okay? It's a well-known, it's obviously an oversimplifying diagram. The amygdala is actually a very small part of your brain, which is where fear responses are most pronounced. And what it says is you have at least 2 routes, you see? So you have the information coming from the outside world, you have this thalamus, which is like a router, you know, sending your information around the brain, and it goes immediately goes to your amygdala, and then it also goes like indirectly to the cortex, through these areas of your brain which evolved much later, okay? So, and this happens within milliseconds. This could take 200, 300 milliseconds. So what I think we're seeing in VR, and again, it's something very difficult to prove scientifically, is that, you know, some parts of your brain, they don't know that it's a VR simulation. You know, these parts evolving, you know, millions of years ago, they don't know what is pixels, they don't know, they've never heard about Oculus or Facebook, you know. And these parts, they do know. These parts of your brain, they do know about it. So I think this is what happens in the VR. And maybe it's kind of something that also happens in everyday life, okay? But in VR, it was really interesting to see. So this was my second point, and this is where you know, when in my lab or in my research, we work a lot with psychologists and with neuroscientists, but our question is not really what is the self, not from a humanities perspective, and not from a psychology or social neuroscience point of view. Our study is about the relationship between humans and technology. And at least now we are in the stage that we kind of see in the discussions around our research how deep the technology, how deep the part that technology plays in the emergence of human beings. So right now we see, and there is, some of you might have heard of the extended mind theory, Chalmers and Andy Clark. So it goes with this kind of thing with those who are following this line of research. I think it's more the philosophers of mind who are talking about it, but it makes a lot of sense for us from coming from a technology point of view to view you know, what we are right now in 2017 as a result of a lot of it is about technology. And again, if you think about it from an engineering point of view, trying to build robots, trying to build virtual reality, so there are a few arguments of why technology has shaped us so much. And so there is the energy argument. The claim made by the extended mind theory is that we will do whatever we can to offload ourselves to external objects, to objects. Okay, the first example is navigation. So it used to be a map. You don't want to remember all the details, you use the map. Then today it's Waze, in Israel at least we use Waze. We offload it. And from an energy point of view, it makes a lot of sense. You know, the brain is very efficient, it's an amazingly efficient machine, but it consumes something like 20%, I think, of the energy of our body, still unproportional to the energy that we waste. So it wastes a lot of energy. the brain. And so it makes sense from an evolutionary point of view that the brain would try to keep inventing things that would save it from using energy. This accelerating technological progress that we are seeing. It makes a lot of sense. Again, if you think like an engineer, if you think of evolution as an engineer. So it makes sense that our brains would build digital extensions, or technological extensions, which these days are digital extensions. The next argument, so, okay, you've seen something of the computational argument maybe in Thomas Metzinger's view. I hope it's kind of, my hints are clear. There is also the biological argument saying, look, biologically we are almost identical to animals. You know, rats and you know they all have the same brains, especially if you talk about monkeys and primates, right? So the difference between us biologically and animals is negligible, genetically also. But I would like to think that we are very different now from animals. So the only reason could be technology, okay? And the way we look at it from a historical point of view, and again, maybe some of you know better than me, is this scaffolding point of view, okay? So, you know, there was, well, you know the story, I'm sure. There was language, and then there was the print, and there was the internet, and computing. But if you look at it from an engineering point of view, if you are building human beings, it makes a lot of sense that you build a layer, and then you don't need to know, you can offload all kinds of things to the external world, to the technologies we are building, and you can allow what's left, which is us, you know, the human beings, to deal with more interesting stuff, okay? Because the technology takes care of things that we used to have to take care of, like memory, and now we are free, the brain is free to do more interesting stuff, okay? So this is the view coming out from the extended mind theory. And this is where we are in a very interesting point in time, because we have, you know, we have all these technologies, and I hope you understood the message from Mel that, you know, virtual reality can, in very, very fundamental way, alter your sense of self. Okay, you know, in science you show it by looking at what Thomas would call the minimal self model. You know, all these representations of the body, but I'm sure it applies to many other layers. And so we are in a very interesting time. I don't know if you're following this, but VR has been around, so like 50 years. But now Silicon Valley is really, there's really a transition point where it's going into, it's going to be in everyone's everyday life, you know, sooner or later. Don't know if it's going to be 217 or 222, but Silicon Valley is now spending billions of dollars on these virtual reality technologies, the same ones that Mel was describing. So I think it raises really interesting questions about the next levels of our co-evolution with technology. So here is one example. This is actually a relatively old example of research that we did, of course, with Mel. I think Mel, the proxy was your idea to introduce it into beaming. But anyway, so this is just an illustration. If I can play this video, I actually want to play. No mouse. Why is there no mouse?
I will see the mouse.
You see it. Ah, that's good. Maybe it's better. No. Oh, come on. No, this one I want to show you. I guess there might be some conversion problems, but let's quickly Safari.
What were you looking for?
A web browser. Let's do it very quickly. Yeah, we can do this. Yeah, keep it. Ah, my phone is ringing. That's very useful now. Wow, this is really tough. Okay. I hope it was worth it. because this is based on a true story. It's a mock-up illustration of the real technology that we built. This is in a virtual world Second Life.
Christmas season has just passed, and people are returning to work at full steam. Please meet Dr. Beatrice Herzliya, an expert in communications and media psychology. Currently, she is swarmed with work.
Hey, Beatrice.
Hi,
How are you?
Good.
Yeah, I just wanted to make sure that you remember your lecture at the virtual convention in Second Life.
Yeah, thanks for reminding me. Of course I remember.
I hope so. There are some Chinese students, imagine that, who have involved in it due to last year's success.
Oh, really? Oh, that's good to hear.
Okay, I see you have such a busy voice, so you are doing it, and I hope it will be good. See you then.
Okay, see you. Bye-bye. Fortunately, Beatrice is not on her own. She has a little help from someone very close, someone who can take on the role of her. Please meet Beatrice's proxy. With surprising AI abilities, this is the best replacement for yourself in the virtual realm.
Virtual world which still exists, with which people spend time. And in this case, it's a real story that we were invited to give a talk in a virtual world conference. And we sent the automated proxy instead of Beatrice. So what you see is a mock-up video, but this actually happened, kind of.
Beatrice's proxy has found a place, and the lecture is taking place as scheduled, with a presentation which was audio recorded in advance.
We can eliminate cultural characteristics such as race and clothing by designing cultural neutral avatars. Alternatively, we can design cultural stereotypical avatars if we want to make the differences among them visually salient.
Okay, so there's questions and answers, and I'll just show you.
Even though the proxy does not want to disturb Beatrice, knowing that she is working very hard, there are some things that the proxy is unable to decide on its own.
Here's another one for you.
So we've done a okay, so you understand the punchline. And the point is that we've done a series of these studies. Okay, so I'm going to wrap up soon, but so the idea is that we've done, this was in Second Lab, this was 2010, and then we've done a series of studies, some in collaboration with Mel, some in our lab, where you have, we play with this idea of mixed control. Imagine you have, so we are all now part of, we spend a very large percentage of our time in digital spheres, and we have all kinds of representations, like Facebook accounts, but this could also be the avatars or robotic representations. There's actually companies now renting robotic representations that you can control remotely to go to work or to attend a remote exhibition. And so we can show that these representations can be, on the one hand, fully automated AI. They can be fully controlled by you, but we were also looking at what happens in the middle. Okay, so you are controlling one aspect or some aspects of this representation, and some algorithm is controlling other aspects of your representation. Okay, so I'm going to wrap up more or less here. I'm not going to answer the questions, of what does it mean, but I think our self is also, I'm sure it's many other things, like you will hear from the very good speakers that Professor Kleinberg is inviting. The self is also very much a technological construct, and is driven by technology throughout the ages. And these days, these are the technologies that we are that are shaping us, And they're dominated, by the way, not by Mel Slater, but by Silicon Valley. Okay, so Silicon Valley are the ones, and the Israeli high-tech industry are the ones that are deciding who we are. That's my take-home message. Okay?